A very warm welcome YouTube family. In this particular video, we are going to discuss about another mystery that is still unfold, and this time the topic is dark matter. So here we begin. So what is dark matter? How can we define dark matter? Does it really exist? So starting with the definition of dark matter, we say dark matter is a mysterious substance that makes up about 85% of the total matter in the universe. Unlike ordinary matter, which interacts with light and other forms of electromagnetic radiation, dark matter does not. This makes it extremely difficult to detect directly, unlike other matters. Now, I am damn sure you guys will be thinking, is there any evidence that confirms the existence of dark matter? Yes, there is, and that we are going to discuss. While we can't see the dark matter, the existence is basically concluded from the gravitational effects on the visible matter. Several observations have been made by several scientists and the astronomers regarding the existence of dark matter. But here we will primarily discuss about two major observations, and that basically includes the first and the foremost galaxy rotation curves, and the second one is gravitational lensing. So in general, what we have studied till date is all the planets, the stars, basically revolves in elliptical orbits around some fixed central point. That central point can be sun as in the case of the planets and can be center of the galaxy as in the case of the stars. So what we know that जब planets या stars, like if we consider a particular star that is revolving around a particular central point of a galaxy, सो वो अपने ऑर्बिट में रिवॉल्व कर रहा होगा. सो देयर वेर बेसिकली टू पॉइंट्स, वन इज कॉल्ड एज एपहेलियन एंड सेकेंड वन इज कॉल्ड एज द पेरीहेलियन. So aphelion is basically that particular point which is far away from the center, and perihelion is the one that is close to the center, as it is a case of elliptical orbit and the galaxy being at one of the focus of the orbit. So we know, like जैसे हम जानते हैं, we have studied the gravitational force, about the gravitational force, and we have also studied the Newton's law of gravitation, and there we have studied a formula F is equal to z m1 m2 divided by r square. So there we can say that if we say the mass is constant, then we can say that the force of gravitational is inversely proportional to the square of the radius. That means in simpler words we can say that अगर हम रेडियस को इंक्रीज करते जाएंगे, सो इन दैट पर्टिकुलर केस जो फोर्स ऑफ ग्रेविटी होगा और द ग्रेविटेशनल फोर्स होगा बिटवीन द टू बॉडीज, द मैग्नीट्यूड कीप्स ऑन डिक्रीजिंग. This is a general thing that is observed, and as a result of which, if the force of gravity will decrease, no, the planets or the stars will accelerate at a lower speed, so the speed will also decrease as we keep on moving away from the center. And one more thing that can be that can be taken into account in order to justify that the planets suffer a loss in velocity or the speed as the distance from the center or the focus increases. That can we can say that we can prove this on the basis of the conservation of angular momentum. So we can say that the particular equation is m omega r equals to constant. So for the same body, if the mass is same, then we can say that omega 1 r1 is equal to omega 2 r2. Now see, very clear, like simply you see, like if r1 and r2 are the two locations, like one is nearer to the center point and two is bit farther away from the central point, so r1 will be less, okay, and r2 will be more. So if we want both the terms on the LHS and RHS to be equal, like omega 1 r1 should be equals to omega 2 r2 for the conservation of angular momentum, then in that particular case omega 1 has to be greater than omega 2, isn't it? Then only the product omega 1 r1 will be equal to omega 2 r2. सो हम यहाँ पे कह सकते हैं कि बेसिकली क्या हो रहा है कि अगर हम इसको सिंपलर वर्ड्स में कंक्लूड करें तो हम ये कह रहे हैं कि जब हमारी डिस्टेंस सेंट्रल पॉइंट से इंक्रीज हो रही है, लाइक r2 इज मोर देन r1, then omega has decreased because omega 2 is less than omega 1. So omega is angular velocity. So if angular velocity decreases, then that particular case tangential speed also decreases. So that's why we say that at farther points the speed decreases. As we keep on moving away from the center, the speed keeps on decreasing. But this is not the case here, because if you see the first point carefully, in the galaxy rotation curves, there it's written the speed at which stars orbit the galaxies doesn't decrease with distance. हमने क्या पढ़ा? हमने अभी जस्ट वी हैव स्टडीड और व्हाट वी नो और व्हाट वी हैव कंक्लूडेड और व्हाट वी हैव स्टडीड टिल डेट कि हमने यही पढ़ रखा है कि अगर हम सेंट्रल पॉइंट से दूर जाएंगे, रेडियस इंक्रीज होगा तो ऑब्वियसली स्पीड डिक्रीज होगी. बट यहाँ पे लिख रखा है कि the speed at which the stars orbit galaxies doesn't decrease with distance. मतलब with the increasing distance, speed is not decreasing at all. It is remaining constant. What? How? How is it possible? No, 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 no. Just tell me how is it is possible. Is it possible really? So it is possible because it basically happens because of the existence of dark matter. थोड़े लेमन लैंग्वेज में बात करते हैं. Like see, जनरली होना चाहिए था ग्रेविटेशनल फोर्स हैज़ टू डिक्रीज एज अ डिस्टेंस इंक्रीज. ग्रेविटेशनल फोर्स डिक्रीज हो रहा है तो एज अ रिजल्ट ऑफ विच द एंगुलर वेलोसिटी विल ऑल्सो डिक्रीज. बट यहाँ पे ये चीज़ नहीं हो रही है. अब देखते हैं ग्रेविटेशनल फोर्स के इक्वेशन में. सो इट्स G m1 m2 डिवाइडेड बाई आर स्क्वायर. सो ठीक है, आर वाले टर्म को अगर नेग्लेक्ट करें तो इट इज़ डायरेक्टली प्रोपोर्शनल टू मास. सो दैट मीन्स देयर इज समथिंग विच इज कॉन्ट्रीब्यूटिंग टू द इंक्रीज इन द ग्रेविटेशनल पुल and that is actually the additional mass because it is directly proportional to mass. तो अगर mass को increase करेंगे तो force of gravity will also increase. So that additional mass is itself the dark matter. Now moving ahead to gravitational lensing. So yeah, this is one of the most important, most researched topic in astronomical physics, and it is very much similar to that of the phenomena that we have observed when light passes through a kind of optical lens. So let's have a look about gravitational lensing. So it says massive objects bend the path of light, a phenomena known as gravitational lensing. Observations of this effect suggest the presence of unseen mass clusters referred to as the dark matter. This is going a bit theoretical. So let's make it a bit practical and have a look through an animated video. Now just see this particular animated video. This video I have obtained from the NASA website. So can you observe in this particular video, it is very clear that there has been some bending of light that has been observed at the center point itself. Light is coming from some fixed source of point like some another galaxy in a straight path, and after that it is start bending at some location, and after that it reaches again and gets converged. So if we try to look from the other location where it is getting converged, ऐसा लगेगा कि लाइट जो है वो कहीं और से आ रही है. If we see from the other point तो ऐसा लगेगा कि लाइट कहीं और से आ रही है. Actually it is coming from this center of the galaxy itself. It will appear to us like it is coming from somewhere else. So this is basically happening because of the presence of the dark matter. Okay, so light going through a gravitational lens is similar to light going through an optical lens. It gets bent. When light from distant stars passes through a galaxy or cluster, the gravity of the matter present in the galaxy, the mass of the matter present in the galaxy or the cluster causes the light to bend, as a result of which the light looks like it is coming from somewhere else rather than from its actual origin. And this amount of bending that is actually taking place helps the scientists to study the amount of dark matter usually present. So to make the concept clear, let's move to the second video. And this is the second video that we are going to see. So this animated video I have taken from the ES Supernova website. And this is much more, interesting and will make you more clear about the thing that I am talking about. Okay. So this video basically shows a phenomena known as gravitational lensing that we are discussing about. And this dark matter is actually very helpful also. Like, not only it is distorting the image, but also it is helping us in some manner that we will discuss in this particular animation video itself. So like see, you can see this particular video. In this particular animation video, there is a distant galaxy, a galaxy which is at a very far distance. In the video it is appearing bit closer, but actually it is at a very far distance. And because of the fact that it is at a very far distance, very less amount of light from this particular galaxy is traveling and reaching to the earth. So like see, initially the light is going straight. See, the rays are going like straight and straight only. But as soon as the cluster of galaxies gets accumulated in between, or in other words, we say if we add a galaxy cluster to this particular scenario between the space that is present within the galaxy from which the light is coming, or the source, and the earth or the observation point where the light is being received, अगर इन दोनों के बीच में मतलब जो गैलेक्सी जो डिस्टेंस गैलेक्सी है, लेट्स कॉल इट एज गैलेक्सी ए। सो अगर जो गैलेक्सी ए है, अगर हम उसको अपना सोर्स पॉइंट लेते हैं और अर्थ हमारा ऑब्जर्वेशन पॉइंट है, अगर उनके बीच में अगर हम एक क्लस्टर ऑफ गैलेक्सी को ऐड ऑन कर दें, सो वी विल सी द लाइट इन स्टीड ऑफ गेटिंग passing through straight path, it gets bent. It is forming a curve path. We can easily observe that how the path of light basically altered from being straight to curve. And because of this particular factor, there is one good thing also, that the amplitude or the intensity of the light basically gets amplified, because of which we can observe or we can have a look about the objects which are very at a far distance from the earth surface as well. So that is basically making that thing easier as well. बट बिकॉज ऑफ दिस फैक्ट व्हाट हैपेंस इज लाइक, अगर हम अर्थ से देखेंगे लाइट को रिसीव कर रहे हैं तो हमें लगेगा कि लाइट एक्चुअली वहाँ से आ रही है, नहीं नहीं लाइट यहाँ से आ रही है, एक्चुअल सोर्स से लाइट हमें लगेगी नहीं आ रही है, कहीं और से आ रही है, ऐसा हमें फील होगा. सो एज अ रिजल्ट ऑफ विच वी आर गोइंग टू गेट अ डिस्टॉर्टेड इमेज एंड मल्टीपल इमेज. सो दैट्स a thing to be recorded here, that we are getting distant we are getting a kind of multiple and distorted image of the same galaxy because of the presence of the dark matter. So these all phenomena taking place confirm the existence of the dark matter, and the amount of bending that is actually taking place can help us estimate the amount of actual dark matter that is present there. So let's understand it through an example. So let's imagine a trampoline. You guys must have seen, or some of you might have jumped on a trampoline as well. So just imagine the space as a giant trampoline. So like when you will place a heavy ball in the sense like it is very massive, it is having a great mass, and that massive object is the galaxy itself. So if you place a heavy ball on it, what will happen? ट्रैम्पोलिन है, ट्रैम्पोलिन पे अगर आप चढ़ते हो और बीच में जाकर आप जंप करते हो, या आप जाकर अचानक से उससे बैठ जाते हो, तो क्या होता है ट्रैम्पोलिन का, जो उसकी फैब्रिक होती है वो वॉप हो जाती है, इन द सेंस लाइक उसमें ऐसे कर्व्स बन जाते हैं, ठीक है, एक वी शेप ले लेता है वो. So similarly, if you place a massive object, and here the massive object is resembling our galaxy, so if we place our galaxy on the trampoline which is representing the entire space, the trampoline will bend. That is what actually happens in the real life also. Now, if you roll a marble, and that marble is representing here the light, so if you roll a marble past the ball, the marble or the light will not go in a straight path, rather it will bend, it will get curved around the ball because of the bending that is taking place in the trampoline. So this is actually what dark matter is doing in the universe. It is basically very massive, and because of its huge mass, it is causing the light to get bent instead of being getting traveled in a straight path. So in short, we can conclude that massive objects bend the fabric of space-time, and light traveling through this bend gets curved. This can make distant objects appear distorted, in fact magnified, and at the same time we can have multiple images of the same thing. And hence it solved the topic dark matter. So hope you like this particular video. If you want such more interesting topics to be discovered by me, to be taught by me, so do mention it in the comment box. Share, subscribe, and do press the bell icon. Bye bye.